When a language model agent encounters a complex web task, should it commit to its first decision or explore alternatives? This paper introduces a powerful answer: tree search algorithms that let agents backtrack, explore, and find better paths to success. Building on this challenge, the authors identify a critical limitation. Existing agents typically commit to action sequences without systematic exploration. When navigating complex web environments with thousands of possible actions, this greedy approach leads to compounding errors that derail task completion. The researchers propose a fundamentally different approach to agent decision-making. The algorithm works by maintaining a frontier of states to explore, guided by a learned value function that estimates success likelihood. At each iteration, it expands the most promising state, sampling multiple actions, and evaluating their outcomes before committing to any single path. This visualization shows the core mechanism. The algorithm maintains a frontier of candidate states, evaluates each using the value function, and expands the most promising ones. The value function itself uses a multimodal language model, with self-consistency prompting to estimate which states are most likely to lead to task success, making the search both efficient and reliable. These results represent substantial progress toward autonomous web agents. The improvements come from the algorithm's ability to explore beyond initial action samples, effectively pruning non-viable trajectories while identifying paths that baseline approaches would miss entirely. Here we see the algorithm's practical advantage in action. The top row shows where a greedy agent would have failed by committing to its first sampled actions. The search algorithm, however, explores alternatives, backtracks from the unproductive path, and discovers the successful trajectory shown in the lower branch. This backtracking capability directly addresses the compounding error problem that plagues traditional agents. This comparison highlights the fundamental shift in agent architecture. While baseline approaches make decisions sequentially without recourse, tree search enables systematic exploration and course correction, transforming how agents navigate complex task spaces. While powerful, the current implementation faces practical deployment challenges, particularly the computational cost of backtracking through environment resets. The authors identify promising directions for refinement, including smarter identification of which actions can be undone without full resets, and more efficient value function architectures that could further streamline the search process. This work demonstrates that tree search fundamentally enhances what language model agents can accomplish, turning exploration from a liability into a strategic advantage. To dive deeper into the methodology and see more examples of how search transforms agent behavior, visit emergentmind.com.